Hello, this is Sir Alex again. During my last video, I discussed about algebraic concepts, terms, um, polynomials, coefficients, right? So those things. But now, I'm going to discuss with you how we manipulate these terms, how we add, subtract, multiply, and divide the easy way. All right? You ready? Okay, let's start. All right, there you go. Okay. So we're going to add, subtract, multiply, and divide terms. But before we do that, we need to distinguish like terms from unlike terms. So from the definition, when you say like terms, we're referring to same variables and same degree or exponent. Okay? Unlike terms, they are different variables, or they may be same variables, but they have different degrees or exponents. Okay, so these are examples of like terms. 3x, 4x, negative 2x. Okay. 5xy, negative xy, 6yx. Okay. 3x squared y, negative 2yx squared, xy squared, or x squared y. There. The positioning of the variables is not important as long as they have the same degree or same exponent. So I can combine 3x, 4x, and negative 2x. Okay, I can combine 5xy, negative xy, and 6yx. The arrangement of the variables does not matter. So I can add or subtract 3x squared y, 2yx squared, and x squared y. Notice the degree of x is 2. Okay, the exponent of y is 1. It should be constant throughout. X squared, x squared, x squared. Y, y, y. So those are like terms. How about unlike terms? I think this is very obvious, no? When you say unlike terms. X plus y. Now let's say xy. Those are unlike terms and you cannot add it. Okay? 3x, 4x squared. Okay? Let's say 6x cubed. X, Y, Z. Those things. Right? 3/5 of xy, 4x squared y, negative 5 xy squared. So those are unlike terms. And we can't combine them. We can just copy them na lang when we add or subtract. Alright? Here we go. Let's start adding. Okay. 3x plus 2x, 5x. Right? 7x plus negative 6x. Remember my integers? Two different signs, get a difference. That's 1. And then assign the sign of the larger number, that's 7. So the answer is 1x. You don't actually write the 1 anymore. It's obvious it's 1. So 7x plus negative 6x is just x. Okay? Negative 2x squared y plus 4yx squared plus x squared y. That will give us negative 2, 4, and 1. Okay? You can put 1 here. Why not? Okay. Negative 2 and 4, that's positive 2. then 1, that'll give us positive 3. So 3x squared y. Pretty easy, right? Just mind the constants there. Negative 2 plus 4, that's positive 2, plus 1, positive 3. Okay, but the very first thing you need to do is to see to it that the variables are the same. The terms are similar or like terms. There, that's how you add them. Okay? Or let's say add subtract. Why not? Let's add 4ab minus 3ba plus 6ab. There. AB, BA, the same. 4 minus 3, that's 1. 1 plus 6, that gives us 7. There. Easy. Right? That's it. That's how you add the subtract terms. Okay. What if it's unlike terms? There. Okay. So add or subtract unlike terms. What do we do when the terms are unlike? 3x plus 4x plus 5y minus 6y. Okay. Let us combine like terms first. 3 and 4, that is 7x. 5 and negative 6. Remember, make it plus, then put negative sign to the next term. So 5 plus negative 6, that's negative 1y or negative y. There. So 7x plus negative y. So that's the answer. You cannot combine x and y because they're unlike terms. What you can do is you can copy. Or you can also write this as 7x minus y. They're just the same. Okay? There. 3, 4, 7, 5 minus 6, negative 1. Or you don't have to put the negative 1 there, just put the negative sign, negative y. So it's 7x minus y. Okay, let's do another one. 5x squared y plus 2xy minus 4yx plus y squared x. Okay, so it's a combination of like and unlike terms. How do we go about adding or subtracting them? Let's look. X squared y, do we have a similar term? Nope. So let's just copy it. So that's 5x squared y. Notice these two terms are similar. xy, yx, they're just the same. So 2 minus 4, make it plus, then put assign a negative sign here. So it's 2 plus negative 4, that's negative 2xy. Or if you want, you may write 2yx, it doesn't matter. And then this is different from all of this, so just copy it. There. Okay, so this is the answer. Remember, if you cannot combine like terms, might as well copy all the terms. Okay, I copy this, I copy that, then I simplify these two terms because they are like terms. Very easy. All right, there. Now, how do you multiply terms? Okay, we're now in multiplication. Now, it will not matter anymore if it's like or unlike terms. Okay? You can multiply unlike terms. You can multiply like terms. It doesn't matter. You can divide like and unlike terms. All right? Let's try. 4x times, let's say, 3xy. There. I can multiply 4 and 3. I'll get 12. I can multiply x and x. I'll get x squared. And y, I'll just copy it. Okay. In algebra, okay, we need to know the laws of exponents. Okay. These are the laws of exponents. Number one, there are three basic laws, right? X raised to, let's say, an exponent called m multiplied by x raised to an exponent that's n. You can combine them by adding them. There. It happens only in multiplication, right? Next, when you divide, okay, you subtract the exponents. Notice that they have two different exponents, meaning they have different degrees, which means they are unlike terms. Like what I said before, you can multiply or divide unlike terms, okay? But see to it that the base are the same. These are the base or the bases. These are the exponents, okay? The last rule is when you raise a power with another power, there. When you raise x raised to m with a power that's n, what do? You multiply. There. So here you add, if you have two terms, two unlike terms, same base, you add exponents. If you divide two terms, same base, different exponents, just subtract. And when you raise a term having an exponent with another exponent, just multiply the two exponents. That's it. Okay? So applying those laws here, this is what we got. So 4 times 3 first, that's 12. X times x. If you don't see an exponent, it means it's 1. 1 plus 1 is 2. First law. Okay? And then just copy the y. So you'll get 12x squared y. Right? Negative 5xy. 3x 6y squared. What do we get? Okay, so negative 5 times 3 is negative 15. And negative 15 times 6, let's check, that's 30, it's 90. Okay, so negative 90. Begin with the constants first. So negative 5 times 3, that's negative 15. Negative 15 times 6, that's negative 90. Right? And then look at this. X raised to 1, y raised to 1, x raised to 1, y raised to 2. 1 plus 1, that's 2. So x raised to 2. Okay. Y raised to 1, y raised to 2. Add the two exponents, y raised to 3. Simple as that. Okay. Check. x1, x1, x2. y1, y2, y raised to 3. Okay. Another example. Just remember the laws again. Same base, different exponents, add. Same base, division, subtract. Just one term, raise it to another power, multiply the exponents. Okay, one last example. Okay. Negative, how about fractions? Negative 4/3 n times 3/5 m squared n times, let's say, 5 n squared. Okay. In my last videos, I discussed cancellation. Okay, the easiest way to multiply fractions or to multiply integers is to simplify them first. Okay, look at this. I see a 3 here, I see a 3 there, so I can cancel it. How? Divide both of them by 3. 3 divided by 3 is 1. 3 divided by 3 is 1. I can see 5 here, I can see 5 there, so just cancel it. See, it makes your computation so easy. Okay, so this becomes 1, this becomes 1. Okay, so we only have 4 here. So let's write the 4. Oh, don't forget the negative sign, that's very important. There. Okay, m squared. So that's m cubed. N squared, n to the 4th. So easy. There. See, 2, 3, 4. 1, 2, 3. All right? There. Now, there's the fourth rule that we should remember. After there are 5, now the fourth rule is this. If any term is raised to 0, the answer is always 1. Except 0 raised to 0. The answer there is undefined. Okay? So any number, any variable raised to 0 will give us 1 except 0. Okay, another one. Okay. If a term is raised to a negative exponent, might as well make it positive by getting its reciprocal. So if x is raised to negative m, make it positive by getting the reciprocal of the term. There. Simple as that. So that's the fifth rule. But these 3 basic rules that you should always remember. These are very important rules. Also the fourth rule, no? If x is raised to 0, it's always 1. Or any term for that matter. Again, except 0. Because 0 raised to 0, nobody knows the answer. That's why they call it undefined. Okay. Let's go to the last part. So easy. Division. Okay. So 3x squared divided by 4x. Rule number 2. You put 1 here. Okay, you cannot divide 3 by 4, so just copy it. Okay, and then subtract 2 minus 1. 1. Okay, can't forget about this. So 3x over 4. That's the answer. Okay. 8x squared y cubed divided by negative 2x cubed y. How do we divide it? Let's start first with the constants. 8 divided by negative 2 is negative 4. Okay. And then 2 minus 3, negative 1. Remember the integers I discussed? So 2 minus 3, that's negative 1. And then y, 3 minus 1 is 2. There. But how do we write it properly? Okay, so it should be written as negative 4y squared over x. Okay, this is the proper way to write it instead of this one. Although this is correct, technically it's correct, but I prefer you writing it this way. Okay, that's the proper way. Okay, one more, then we're done. Let's say negative 12a squared b squared c raised to 0. Okay, all over 7a 7 b0 c raised to 2. There. How do we divide that? Let's start with the constants. So it's negative 12 over 7. There. Look at this. 2 minus 7, that's negative 5. 2 minus 7 is negative 5. And then we can cancel this because that's 1. Remember, any term raised to 0 is 1. Okay. And that's just copy. B squared, C squared. Now, writing that term properly, we'll have negative 12b squared over 7a raised to the 5th power c squared. That's the proper way to write the answer or the term. Okay, let's check. 12 over 7. 2 minus 7, that's negative 5. Bring it down to make it positive. And then b squared is here, and then c squared is there. All right? Very simple. Just takes practice. Okay, so what have we learned today? Okay, we learned how to differentiate like terms from unlike terms. And we can add like terms, but we cannot add unlike terms. Okay, we just copy them. But when it comes to multiplication or division, we can do the computation for like and unlike terms, like our example there. Okay, so in my next video, okay, I will discuss with you word problems. How do we apply algebraic expressions in our daily life? That's the heart of my discussion. That's the heart of algebra. How do we apply those things that we learned today in our daily lives? Right? So stay with me. Like, subscribe, and believe. All right? Believe that you can do it, and believe Sir Alex. Practice makes perfect. Okay? Bye-bye.